Hey guys, I'm Tiger, and I'm going to teach you about C++. This is part 3 to C++ Basics, and if you haven't checked out part 1 or part 2, make sure you check them out first. I've linked them in the description. Hit that like button if you've learned anything new in this video, and click that subscribe button if you want to see more videos on C++. So first, let's talk about the iostream. So the IO part of iostream stands for input-output, and the input-output library or IO library contains functionality that allows printing to and receiving input from the console. And to use functionalities from this library, we need to include the iostream header at the top of the file. So for our programs, we'll have to include this line at the top of the file, and then we can use its functionalities like after it. std_cout is one of the few predefined variables in iostream. You've seen it in the hello world example that I've shown you, and it allows us to send data to the console as printed text.
So as I stated in part 1, cout stands for character output.
To use this variable, we use an insertion operator, which shares the same symbol as bitwise left shift, with std_cout at the left-hand side and the object to be printed as the right-hand side. std_cout can print more than just plain text. It can also print numbers and even the values in variables. So it can also print more than one values in a single statement by linking more of this symbol. So in our example program over here, we have the include iostream for std_cout, and then our main function, and then every time we print, we have this insertion operator, and then it sends hello world into std_cout, so it prints it out, and also it can print more than just plain text. It can print numbers, and then also it can also print variables.
This first prints out hello and the world, and when we piece them together, it's hello world. We can also use different types, like over here it prints x's value is 5 because we've initialized x with 5.
So separate print statements doesn't result in separate lines. The std_NL stands for end line, and printing it through std_cout moves the cursor to a new line, and then std_NL in line 11 in our example over here is not necessary, but it helps indicate that the printed line is a complete thought. And if we run this program, then our output is going to be line 1, still line 1, line 2, because after we printed out line 1, we haven't gotten to the next line, and then this is still line 1. And then we have to put an std_NL and then move it to the next line. And then we can print line 2, and then because there's a std_NL, we have a blank line over here. So many programmers prefer using the line break character over std_NL because std_NL actually does two things: print a new line and flush the buffer, which makes sure everything sent to it gets displayed. std_cout automatically flushes its buffer, so using std_NL becomes inefficient. And then the new line character can be used alone, where it has single quotes, or it can be used in double quoted text where it doesn't have single quotes. So like in our example, we have this used alone and also inside this double quoted text. And also it basically still switched to new lines. I prefer using the new line character over std_NL when printing a new line.
Unless if you want to make sure that it gets printed out immediately.
So next we have std_cin. The cin stands for character in. and it's another predefined variable in iostream, and it takes user input from the console and with the extraction operator,
which is the same symbol as the bitwise right shift operator,
and it fills the variables on the right hand side with the extracted
value.
And it can assign values to more than one variable in the same line by linking multiple of these symbols. So in this example, we have a std out and it asks for user input. And then we can use std in, and it uses the extraction operator. It's different from the insertion operator. And then it extracts input to x. So now x has the value of whatever is inputted. And also remember to initialize x. It's actually not necessary in here, but it's a really good practice. And we can also extract multiple inputs into these variables, like std, y, and z. It's going to be filled from left to right, so y gets filled first and then z. And then we can also print out these variables just to make sure they are actually filled in. So here's an example output, and then in green is the input, so that's what the user types. So first prints enter three numbers, 3, 4, and 5. And because the user has to hit enter for the input to be accepted, so we don't have to print a new line over here. And then over here it says you've entered 3, 4, and 5. Now moving on to initialized variables and undefined behavior. Variables that are not given a known value are uninitialized variables. Uninitialized variables may contain whatever junk data the variable address had prior to variable creation or default value set by the compiler, depending on the compiler used. So some compilers will automatically set a default value, some won't. And C++ adopted this behavior from C, which was created when computers are slow. So initializing every variable upon creation would be inefficient back then, such as if you want to store a whole file into a bunch of variables. It's going to be really inefficient if you have to initialize all of those variables. Not all languages have this behavior. Like languages such as Java will give variables a default value upon creation if no value is specified, and also it's specified by the Java language, so it doesn't depend on the compiler. So always initialize variables upon creation. We have like a sample program to do this. You can also do this if you want to. It won't make your computer explode. So first we put into x, we don't initialize it, and then we print it out. And then when I printed it out, it says 4200129. It's different depending on the compiler, and it also might depend on whatever junk memory exists. So undefined behavior. Undefined behavior is behavior that is not well defined by the programming language. So using initialized variables causes undefined behavior because C++ does not define what values undefined variables have. So symptoms of undefined behavior includes like different results every time, same incorrect results every time, sometimes incorrect results, and like sometimes it seems to be working but it produces incorrect results. It sometimes even can cause the program to crash, or it only works on some compilers, or it breaks when seemingly unrelated code is changed. So always avoid undefined behavior even if it works. So like if you program something and then it works, but there's undefined behavior, it's best to change the code so it does not have undefined behavior because it might not work for other people. So thank you for watching, and make sure you fully understand each concept in this video. If you get stuck, remember to leave a comment about whatever you're stuck on so that someone can help you. I'll see you in the next video. Bye.